Welcome to a new test and teardown video. This time it's a new IMPO GM amplifier type 1210. So IMPO is a company that specializes in making equipment for schools and all sorts of education places and all that kind of stuff. So yeah, GM, that's of course Geiger Müller. So that is a radioactive detector. Don't you think this DIN connector is rated for high voltages? There's actually quite a lot of millimeters from pin to pin, but not if you touch down here. There's like a half a millimeter down to metal actually on that pin. So, and I mean that is probably a voltmeter and then a counter. You can turn on and off the speaker, power on off. Oh, so there's a big hefty potentiometer in here that is adjusting the voltage for the tube. Other than that, I don't see any kind of info. I did a little Google on this instrument, and on the pictures I found there were like a sticker here stating the voltage for the input, but that is not available on my unit here. I think the first thing we should do is open it and see if we can figure out what is in here. Yeah, we see power supply or power inlet, so maybe the voltage and everything is in here. And this is just a voltmeter, it's not input. This is what I really hope for. And then I hope that I can find any Geiger-Müller tubes, and maybe I can also find a little bit of radioactive material. That is one of the cool things about IMPO. You almost always find those stickers, so we know exactly how old this is. From 89, huh? So the internal parts is just really simple. There's a power supply and loudspeaker, clicker, driver, PCB, and it's only 2 transistors, so that's all what it takes. That pot meter is for the voltage, and I think that is a little bit weird what is going on here, because that center point of that, okay, the red is definitely, yeah, this is high voltage from that capacitor. So I would expect like 300 volts on that one, and it is in series with that one, so that's maybe 600 volts. But how do you do that with a 50k resistor? I mean, is that safe, or is this isolated enough from chassis and all that kind of stuff? And then what else do I see? I see the DIN connector, the using chassis of the connector, and then 2 other pins, the red one and the blue one. And that blue wire goes to a resistor that is connected to high voltage as well. And the red one, I think that one is connected to one little transistor down there. So it doesn't really make a lot of sense to me exactly how can I connect my tube, because I would expect only 2 wires to my tube. But I think that maybe there's a capacitor or diode or something like that in this Geiger-Müller tube assembly they're using. I don't know exactly what they're doing here yet, but let's try and see how much is working here and what is going on. So I'm still trying to get this thing working. So I found one of my old tubes. So see, there's a little wire in there. So this is definitely a Geiger tube as well. And if we look a little bit here, I took it completely to parts. See here, The blue wire is the positive, and the red wire is the return wire. And that is the shielded cable. I'll get back to that in a second. Why? See, the return wire is the red one. And I don't know how easy that is to see, but that one goes directly into the base of a tiny little NPN transistor. And that is connected in a Darlington coupling to the other NPN, and that goes to the ground. Okay, so it is not ground, the return wire here, right? And then the positive high voltage is the blue wire. There's a 10 mega ohm resistor up there, and that is connected to the variable high voltage supply. And then we got two different high voltage systems, and they're in series. One is about 300 and the other one is 300. And then there is a simple voltage divider by a pot meter on the top one, so you can variable the output voltage for your tube depending on how sensitive you want it, or if it's a big or small tube and all that kind of stuff. And then you just have two high voltage windings on the transformers. So that is actually the more or less the entire circuit. There is another low voltage capacitor that is doing the click click together with the transistors and the loudspeaker, and that output also goes to the counter connectors. But unfortunately it does not work. So my idea is that maybe this tube here is not working. I find that really odd. But anyway, now I connect to the Geiger tube that I know is working. This is my good old Geiger counter that's always been working, so I definitely think that that one is working. And let's turn on the power here. So now this circuit is up and running, and of course I shouldn't touch anything now. So then I crank up the pot meter. That's weird. Why don't we hear anything? Shouldn't it say clickety clickety click? Hello? What did I do wrong here? Oh, I got a big shock. Why didn't it click before now? What the heck is that shit? So of course it works. Oh my! But what the heck is the problem? Why didn't it wanna? It's just maybe there's something when you crank up the voltage like that, and then it takes some time before it clicks. Really? See? Now it's the same, and then it starts working. Aha, that is interesting. But anyway, it is actually working. So now I can clean it up and assemble it again, and then write down exactly how it's supposed to work and all that kind of stuff. So let me turn this off again, and let's talk a little bit about the cable. So we've got 3 pins, and the last one here I connected to the ground as well. They of course have the ground for the chassis of the connector. So the whole idea is they're using a shielded cable around the return wire, because that return wire goes directly to the base of an NPN transistor, right? And that one goes directly to the metal outer casing of your detector tube, or it's actually easier to see on this big metal tube like this. So I really prefer designs where the outer metal casing here is actually ground. So that means you can touch it, it's safe, you don't need to worry about anything at all. And then you only have a positive voltage here. And then it's the dip in that voltage that is amplified as, and used as detection. In this circuit, it's the tiny little current that goes through the tube, this strike. And then there's a current going out of the return and into the base, and that is what's measured. But if you do it like that, you can imagine that all this metal here will be a pickup. Like if you touch this, it's going to go hum and it's going to activate the base of this transistor coupling. And this is why they need a shield to encapsulate all this and only leave a tiny little hole for the detector area. And this way everything is shielded, but then there needs to be an electrical isolation around your tube. It's much more hassle when it comes to the mechanic implementation, just because they didn't care to add a little resistor and a capacitor in series with the anode. You know, a series resistor and a capacitor. Then this striking pulse will go to the detector circuit, right? But anyway, it works. So that is pretty cool. So here's the documentation for this connector seen from the outside. So this is how the connector looks like, a normal 3-pin DIN. So imagine this is the connector like that. So the positive goes to the inner pin of your Geiger Müller tube, the little tiny one. So this is the chassis of your tube, and that is the detector input for this system. It's of course also the ground for your tube, right? But then the chassis of the connector, this little pin down here, is a shield you need around your cable, and also a shield you need around your tube, and somehow also allow alpha, beta, and so on to pass through this shield. So, I mean, it must be a very open kind of shield that it doesn't consist of just almost nothing. It must look a little bit special to actually do this, but I think it is definitely possible. And that is definitely how you should do it with this unit, instead of modifying it or anything else like that. So, and then this speaker switch. There's actually one tiny little thing that I do not understand about the speaker here. There's the white wire for the speaker. Try and follow that wire and look where that one goes. So it goes to the connector like that, but it's not really soldered to that point here. It just sticks through. I don't know, it's impossible to film. But that means this orange wire, so when you turn on the sound, then this orange wire is connected to the white wire. But why did they solder it to that side where there's nothing? I mean, it's a little bit weird, and it's definitely not connected over there. And it still kind of works. I don't really got that. Funny. Yes, thank you very much for watching. That will conclude this video. I hope to see you soon again.